look at the next question which I have to discuss. In the previous class, I have discussed the solutions for the questions in the assignment in projectiles up to question number 54. In my previous class, I have discussed the solutions for the questions in the assignment in projectiles up to 54, from 41 to 54. So now I am going to discuss the solutions for the remaining 6 questions in this assignment, that is starting from 55 up to question number 60. So after that, I would like to also discuss one case, that is oblique projection from certain height above the ground. Look at the question number 55. Again, which is showing on, I have shown on the screen. You can look at the question number 55, which is again shown on the screen. Once I read it out again, body is projected horizontally with an initial velocity of 20 meters per second from a height of 160 meters above the level ground. What is the speed of the body at the instant when it is at a height of 595 by 4 meters above the ground? Now take g equal 10 meters per second square. So I am going to discuss this problem. Come on, look at the solution for this problem. So I am going to discuss solution of the question number 55, which I have shown you on the screen. It is given that the body is projected horizontally with an initial velocity of 20 meters per second from a height h equal 160 meters above the level ground. Let O be the initial position of the body from where it begins to move under influence of gravity. The body moves along a parabolic path. You are asked to find magnitude of the velocity of the body at the instant when it is at a height of 595 by 4 meters above the ground. You are asked to find magnitude of velocity of the body at the particular instant when it is at a height of 595 by 4 meters above the ground. Let P be the position of the body at the instant when it is at a height of 595 by 4 meters above the ground. Let small y denote magnitude of the displacement in the vertical direction when it reaches the point P. The displacement y in the vertical direction is measured from the initial position O. So from the figure you can observe y plus 595 by 4 meter is equal to h, which is 160 meters. So the value of y at the point P will be 160 minus 595 by 4 meter. Can simplify this. You get y equal to 45 by 4 meters. To find the magnitude of velocity at the point P in its path, you have to know the magnitude of the horizontal end, the magnitudes of horizontal and vertical components of velocity at P. Vx is the horizontal component of velocity and Vy is the vertical component of velocity at P. In the case of horizontal projection, the horizontal component of velocity at any point P in its path, same as the initial velocity of projection, which is equal to 20 meters per second. So if we use the equation v square minus square equal to a is for motion in the vertical direction, you can write Vy square minus initial velocity in the vertical direction is 0, acceleration in the vertical direction is equal to g. So magnitude of the velocity at the point P in its path is given by root of Vx square plus Vy square. And here you can write Vx equal to u and Vy square equal to 2gy. You can substitute here. u equal 20 meter per second, and g equal to 10 meter per second square, and y equal to 45 by 4 meters. This can be simplified by yourself. So you get under root of 625 meter per second, which will be equal to 25 meter per second. So you get the answer as 25 meter per second. So if you want to copy the solution of this problem, you can copy the solution of the problem. In case you are not finished copying the solution of the problem, in case you need more time to copy the solution, you can take a pause and copy the solution. So I have just discussed the question number 55 now. You get the answer as 25 meter per second. That is second option is the answer. Next I am going to discuss the question number 56. The previous question, what is the speed of the body at the instant t equal root 5 seconds after projection? So in this question number 56 also related to the previous question, where the body is projected horizontally with an initial velocity of 20 meter per second. You are asked to find the magnitude of the velocity of the body at t equal root 5 seconds after projection. So magnitude of velocity at any instant during the motion under influence of gravity is given by root of vx square plus vy square. So in the case of horizontal projection, the horizontal component velocity at any instant is same as the initial velocity projection. And if you use the formula v equal to u plus at for motion in the vertical direction, initial velocity in the vertical direction is 0, acceleration in the vertical direction is equal to g into t. So you can write vy equal to gt. So vy square will be g square t square. To find, you are asked to find magnitude of velocity at the instant t equal to root 5 seconds after projection. So we have to substitute t equal to root 5 seconds. You can substitute u equal to 20 meter per second, g equal to 10 meter per second square. So this you can simplify it. So you get v equal to root 900 meter per second or 30 meter per second. So that's the answer for this question number 56. So answer is 30 meter per second. So if you want to copy the solution of the problem, you can copy the solution of the problem. In case you need more time to copy the solution of the problem, you can take a pause and copy the solution of the problem. So I have just discussed the question number 56. You get the first option as the answer. That is, the answer is 30 meter per second. Next, I am going to discuss the question number 57. A body projected horizontally from vertical height of 40 meters above a level ground strike the ground with a speed equal to 3 times the initial speed of projection. The horizontal distance covered when it reaches the ground is. So I am going to discuss the question number 57. It's given that the body is projected horizontally from vertical height h equal to 40 meters above the ground, and it's given that the magnitude of the velocity just before it strikes the ground 3 times the initial speed of projection. You're asked to find the horizontal distance covered by the body when it reaches the ground. So let O denote the initial position of the body from where it is projected horizontally. The point A lies directly below the point O, and B is the position of the body just before it strikes the ground. So magnitude of velocity, to find this horizontal range, or you have to find the value of u. The magnitude of the velocity of the projectile is given by v equal to the magnitude of velocity of projectile at any instant during the motion under the influence of gravity. You can write v equal to root of vx square plus vy square. As explained in the question number 55, vx can be written as u and vy square can be written as 2gy. At the instant just before it strikes the ground, at the position B, just before it strikes the ground, can take y equal to h. So magnitude of the velocity of the body at the position B, at the instant just before it strikes the ground, is equal to root of u square plus 2gh. So in general, when the body is projected with initial speed u from vertical height h above the ground, the magnitude of velocity just before it strikes the ground will be root of u square plus 2gh. It's given that v equal to 3u here. It's given that magnitude of velocity just before it strikes the ground is 3 times the initial speed of projection. So you can substitute the value of v at b as 3u. Next, you can square both sides here, and you can solve for u square and then u. You get 9u square minus u square equal to 2gh. So 8u square equal to 2gh, or u square equal to 2gh by 8, or gh by 4. So the magnitude of the initial speed of projection, you get root of gh by 2. G is given as 10 meters per second square, and h is given to be 40 meters. So if you simplify this, you get u equal to 10 meters per second. The horizontal distance covered during the motion under influence of gravity, or horizontal range, is equal to horizontal velocity into time of motion. In the case of horizontal projection, the time taken to reach the ground is same as the time taken for a freely falling body which falls from same height. So you can write t equal to root of 2h by g. So r equal to u into root of 2h by g. You can substitute u equal to 10 meters per second square, 10 meters per second, and h equal to 40 meters, and g equal to 10 meters per second square. U is 10 meters per second. So if you simplify this, you get r equal to 20 into root 2 meter. That's the answer for the question. So those students who want to copy the solution of the problem, they can copy the solution of the problem. In case you need more time to copy the solution of the problem, you can take a pause now and copy the solution of the problem. So just now I have discussed the question number 57. We got the answer as 20 root 2 meter. That means third option is answer. Next, I would like to discuss the next question. Look at the question number 58. The body is projected with an initial speed u, an angle theta above the horizontal. Theta is more than 45 degrees. What is the speed of the body at the instant when its velocity is perpendicular to the initial velocity of projection? So I am going to discuss the question number 58. So in this question, this problem is based on the oblique projection, not the horizontal projection. It's given that the body is projected with an initial velocity of magnitude u at an angle theta above the horizontal. So therefore, it moves in a parabolic path. You're asked to find the magnitude of the velocity of the projectile or speed of the projectile at the particular instant when its velocity is perpendicular to the initial velocity of projection. Let P be the position of the projectile at the particular instant when V bar is perpendicular to U bar. That means if you produce the direction of U bar in this way and you produce the direction of V bar at the point P, they are perpendicular. So you have to find the magnitude of velocity V bar at the point P at the instant when V bar is perpendicular to U bar. Let alpha denote the angle which the velocity V bar makes with the horizontal at the point P. So graphically you can draw both the vectors U bar and V bar in this way. So the tail of vector V bar is attached to tail of U bar. U bar is directed at an angle theta above the horizontal. V bar is directed at an angle alpha below the horizontal. So here V bar is perpendicular to U bar. So theta plus modulus of alpha equal to 90 degrees. So modulus of alpha equal to 90 minus theta. The horizontal component of velocity of projectile remains same throughout the motion under influence of gravity. That means magnitude of horizontal velocity at the point P must be same as the magnitude of the horizontal component of initial velocity at the point O. The magnitude of the horizontal velocity at the initial point O can be written as U cos theta. The magnitude of the horizontal velocity at the point P you can write V cos alpha. So you can write cos alpha as cos of 90 minus theta. So cos 90 minus theta you get sin theta. So you get V equal to U cos theta by sin theta. So magnitude of the velocity of the body at the point P in its path is equal to U cot theta. So answer is U cot theta. So magnitude of the velocity of the projectile at the point P at the instant when V bar is perpendicular to U bar will be U cot theta. So answer is U cot theta. So if you want to copy the solution of the problem, come on, copy down the solution of the problem. In case you need more time to copy the solution of the problem, you can take a pause and take your time. So just now I have discussed the question number 58. So third option is answer for this question number 58. So next I am going to discuss the next question. See the question number 59. Body is projected horizontally from vertical height of 80 meters above a level ground. Its speed at the instant when its velocity makes an angle of 37 degrees with the horizontal is 25 meters per second. Its speed just before it strikes the ground is so in the question number 59 it is given that the body is projected horizontally from vertical height h equal to 80 meters above the level ground. It will be the point of projection here. Let U denote the magnitude of initial velocity projection. You are given that the magnitude of velocity at the instant when velocity makes an angle of 37 degrees, alpha equal to 37 degrees with the horizontal is 25 meters per second. You are asked to find magnitude of velocity of the projectile at the instant just before it strikes the ground. Let B denote the position of the body just before it strikes the ground. You have to find the speed of the body at the position B. For that, you have to find the initial speed U. So the horizontal component of velocity of the projectile will be same at all the instant during the motion under gravity. Let P be the position of the projectile at the instant when its velocity vector V bar makes an angle alpha equal to 37 degrees with the horizontal. So the horizontal component of velocity at the point P should be same as the horizontal velocity at O. In the case of horizontal projection, the horizontal component of velocity instant is same as the initial velocity projection. So I can write V cos alpha equal to U. So you are given that V equal to 25 meters per second at the instant when alpha is 37 degrees. So you can take cos 37 degrees equal to 4 by 5. So from this you get the initial speed of projection as 20 meters per second. The magnitude of velocity of projectile at any instant during the motion under the influence of gravity is given by V equal to root of Vx square plus Vy square. So just as I have written in the question number 55, here also we can follow similar procedure. Vx can be written as U and Vy square can be written as 2Gy. Following the method similar to question number 55. So at the position B, just before it strikes the ground, you can take Y equal to H. So the magnitude of the velocity will be root of U square plus 2GH. Can substitute here U equal 20 meter per second, G equal 10 meter per second square, H equal to 80 meters. This you can try to simplify it. So you get V equal to root of 2000 meter per second or 20 into root 5 meter per second. That's the answer. So if you want to copy the solution of the problem, you can copy the solution of the problem. In case you need more time to copy the solution, the problem can take a pause and take your time. So just now I have discussed the question number 59. For the question number 59, first option is the answer. That is 20 into root 5 meter per second. Next, I am going to discuss the question number 20. Look at the question number 20. Two bodies are projected simultaneously from the top of a tall tower horizontally with initial speeds 4 meter per second and 9 meter per second in opposite directions. What time after projection? Their velocity vectors are perpendicular to each other. Take g equal to 10 meter per second square. So this problem comes under the special case which I have discussed in the horizontal projection. That is at the end of the theory for horizontal projection. I have discussed one special case. This problem comes under that special case. So I have discussed that if two bodies are projected horizontally in opposite directions with initial speeds u1 and u2 from the top of a tower, then the velocity v1 bar of one projectile is perpendicular to the velocity v2 bar of another projectile at the instant t equal to root of u1 u2 by g. So I have already derived this result in the theory class on horizontal projection in the special case. I have discussed only one special case in horizontal projection. This result I have derived in that special case. In the given problem, u1 is 4 meter per second and u2 is 9 meter per second. And g is given as 10 meter per second square. So you can simplify this. You get the answer as 0.6 seconds. So answer is 0.6 seconds. So just now I have discussed the question number 60. So for question number 60, second option is answer, that is 0.6 seconds. So with this I have finished the discussion of all the questions in the assignment in projectiles. So before I go to the next topic, I would like to discuss one more case in projectiles, that is oblique projection from certain height above the ground. There are some questions sometimes which may be given based on oblique projection from certain height above the ground, which can be considered a special case of oblique projection. So I would like to discuss one special case in oblique projection. Oblique projection from certain height. Of course, in the assignment in projectiles, there are two problems. In the assignment in projectile, which in the first 40 questions, which are actually related to the same case, but I would like to discuss this case specifically. I consider a body projected with initial speed u from a point O from vertical height h above the ground. Let A be the point on the ground which lies directly below the point of projection. Let suppose the body is projected at an angle theta above the horizontal. Then it moves in a parabolic path. I'd like to discuss on how to find the time taken by to reach the ground and the speed of the body just before it strikes the ground. I choose the horizontal direction passing through the point O at x-axis and vertical upward direction as positive y-axis. So the initial loss of projectile can be resolved into two rectangular components along the horizontal and vertical directions as I discussed in the theory of oblique projection. The horizontal component of velocity, the horizontal component of initial velocity at the point O will be given by ux equal to u cos theta. The vertical component of initial velocity, the point O has magnitude u sin theta directed vertical upwards. First, I would like to discuss how to find the speed of the body just before it strikes the ground. Next, also I would like to discuss how to find the time taken to reach the ground. Suppose B is the position of the body when it cuts the x-axis. That means B is the position of the body just when it returns to the same horizontal plane through the point of projection. As I discussed in the past, the magnitude of velocity at B will be equal to u. And velocity at B makes an angle theta below the horizontal. Let's see with the position of the projectile just before it strikes the ground. So the coordinates of the position C can be written as r comma minus h. Here r is the total horizontal distance covered by the body when it reaches the ground. So the displacement in the vertical direction will be equal to minus h at the position C. As I discussed in the theory of oblique projection, the velocity of the projectile at any instant during the motion under influence of gravity in terms of the displacement y in the vertical direction is given by v equal to root of u square minus 2gy. At the position C, just before it strikes the ground, you can write y equal to minus h. So you get v equal to root of v at the point C. U square minus, substitute y equal to minus h there. If you substitute y equal to minus h, you will get v equal to root of u square plus 2gh. That means in general, the body is projected with initial speed u from vertical height h above the level ground. The magnitude of velocity just before it strikes the ground will be root of u square plus 2gh, irrespective of angle of projection. So whatever may be the direction of projection, whatever may be the angle of projection, whenever the body is projected with initial speed u from vertical height h above the level ground, it strikes the ground with velocity of magnitude u root of u square plus 2gh. For example, large number of balls are projected. Number of balls are projected with same initial speed u, some same vertical height h above a level ground in different directions. One ball may be projected horizontally, a second ball may be projected vertically upwards, third ball may be projected at 30 degrees above the horizontal, another ball may be projected at 60 degrees to the horizontal. Like that, if we project number of balls with same initial speed u from same vertical height h above the level ground, then all the bodies strike the ground with a velocity of magnitude root of u square plus 2gh. So magnitude of velocity of the body or speed of the body just before it strikes the ground will be always equal to root of u square plus 2gh irrespective of direction of projection. Then coming to the calculation for time taken to reach the ground, we use the equation as equal to ut plus half at square. For motion in the vertical direction, you can say that if let capital T denote the time taken to reach the ground, small t equal to capital T, can write y equal to minus h. So you can substitute here y equal to minus h. Uy into capital T and acceleration in the vertical direction, Ay equal to minus g. Similar quadratic equation I have discussed earlier in one of the special cases in vertical projection. So you can substitute the values of Uy and h and g. You can solve this quadratic equation to find the time taken to reach the ground in case you are given the values of h and u. Of course, Uy equal to u sin theta. If you want to direct derivative formula for the time taken to reach the ground, in this case, is given by t equal to Uy plus root of Uy square plus 2gh whole divided by g, where Uy equal to u sin theta. So after calculating the time taken to reach the ground, in case you are asked to find the horizontal distance covered when it reaches the ground, that means the distance between the points A and C. The horizontal distance is covered with a constant velocity of magnitude u cos theta. So total horizontal distance covered when it reaches the ground is equal to horizontal component velocity to total time. So that's the method we follow. That's the method you can follow in case you are given a problem on oblique projection from certain height above the ground. So next I would like to just discuss one problem based on the earlier discussion, that is oblique projection from certain height. Look at the problem that is shown on the screen. The body is projected with an initial velocity of 40 meters per second at an angle of 30 degrees above the horizontal from a vertical height of 60 meters above level ground. If g equal 10 meters per second square, then find first part of the question, speed of the body just before it strikes the ground. Second part of the question, time taken to reach the ground. So I am going to discuss this problem now. Look at the solution of this problem. So I would like to discuss the problem which I have just dictated, just I have shown on the screen. It is given that the body is projected with an initial velocity of magnitude 40 meters per second, an angle theta equal to 30 degrees above the horizontal from a vertical height h equal to 60 meters above the ground. Of course, it moves in a parabolic path. So you are asked to find the speed of the body just before it strikes the ground. The first part of the question. In second part of the question, you are asked to find the time taken to reach the ground. Let A be the point of the ground which lies directly below the point of projection. C is the position of the body just before it strikes the ground. As I discussed previously, the magnitude of velocity of the body just before it strikes the ground, when it is projected with initial speed u from a vertical height h above the ground is equal to root of u square plus 2gh irrespective of direction of projection. So in the given problem, u equal to 40 meter per second, g is 10 meter per second square, and h equal to 60 meters. So that comes out to be root of 2800 meter per second, 20 root 7 meter per second is the answer for the first part of the question. So if you were given this problem in case for objective type paper, or I mean multiple choice questions, or in any entrance examination, then you can directly use the conclusion I have given. The vertical component of initial velocity is given by uy equal to u sine theta. Here u equal to 40 meter per second and theta equal to 30 degrees. Sine 30 degrees equal to 1 by 2. So you get vertical component of initial velocity as 20 meter per second. The time taken to reach the ground is given by capital T equal to ui plus under root of ui square plus 2gh whole divided by g. Can substitute vertical component of initial velocity equal to 20 meter per second. G equal to 10 meter per second square and h equal to 60 meters. If you simplify this yourself, you get the answer as 6 seconds. That means time taken to reach the ground is 6 seconds. So answer for second part of the question is 6 seconds. So, but in case you are asked to find the horizontal distance covered when it reaches the ground, denoted by r equal to u cos theta into t. Of course, that is not asked in the given problem. Here u equal to 40 meter per second, theta equal to 30 degrees, and capital T is 6 seconds. So if you want to copy the solution of the problem, you can copy down the solution of the problem. In case you need more time to copy the solution of the problem, you can take a pause and take your time.